Okay, I'm back and we're going to do incomplete dominance this time. Remember, the incomplete dominance in complete dominance means that one trait is no longer dominant over another. This is a type of non-Mendelian genetics, meaning it doesn't follow Mendel's 3 laws. So in this case, when something is incomplete, it means that one is not dominant over the other and creates kind of a third phenotype. I like to think about it as mixing paint because often this happens with colors, and often flower colors are what we're using as a representation of this. We are going to use flower colors today in our example because that's the example in your notes. So in this case, we have 3 phenotypes. I'm going to write them over here on the side. Our 3 phenotypes are red, pink, and white. Each of these is represented by a different genotype. Remember, this is what the genes look like. A red flower is called or coded by homozygous dominant. I'm going to use R's. Remember, it doesn't matter what letter you use. A white one is our homozygous recessive. And the heterozygous now becomes the mixing or the third phenotype. That is the big difference. We have this third phenotype that's coded by the heterozygous. Okay, so let's try one. The one in your notes is that you're crossing a red flower with a white flower. So I'm going to put the red flower across the top. Again, it doesn't matter. Just make sure you write each of the alleles. These are our alleles, and together they make a genotype. Each allele goes in one of the columns. And we're crossing that with a white flower. I know that my genotype for white, because I wrote it over here, is homozygous recessive, so I'm going to write it down the side. Now you fill in the Punnett square the exact same way we did in complete dominance. Remember, I bring the alleles down and over, down and over, down and over, down and over. It's kind of like a multiplication table. I can see in all 4 boxes, I've now have the heterozygous. So if I was going to write this as ratios and percentages, I would say that I have a 0 red, 4 pink, and 0 white. Yes, you can reduce this and you can say 0, 1, 0 if you want to. If I were going to write the genotype, remember this is the phenotype, this will now be the genotype, I would write 0 homozygous dominant, 4 heterozygous, and 0 homozygous recessive. Okay, now if I'm going to write the percentages, for my phenotype, it's going to be 0% red. You can write 2 dots if you want. 100% pink. And 0% white. For my genotype, I would write 0% homozygous dominant, 100% heterozygous, and 0% homozygous recessive. Okay, so again, you're completing it the exact same way. The only difference now is that you're heterozygous, the two different alleles, are coding for a new phenotype, which is a mixing between the dominant and the recessive.